So, now let us discuss about the. So we have been discussing what is adsorption and its types, and and the nature of adsorbent. Now we will discuss about the different stages, how the adsorption process in different stages occur. First, let us see how the adsorption occurs in single stage. Before starting with the stages, I would like to inform you about the adsorption isotherms first. Adsorption isotherms. Adsorption isotherms. These adsorption isotherms are the plots or the curves or plots that gives the relation between concentration of adsorbent and concentration or pressure of adsorbate. It gives a relation between concentration of adsorbent and concentration or pressure of adsorbate. Here we have two parameters because we consider a fluid solid operation as adsorption, right? So fluid can be either a liquid or a gas. So the adsorbate adsorbate is nothing but the solute particles of the fluid, may be either from a liquid or a gas. So if liquid is used, we go for concentration, or else if pressure is used, we go for adsorbate. Okay. Now, because of these isotherms, there is a relation known as Friendless equation that is being developed from these isotherms, which is given as C star is equal to K into x by m to the power of n. P star is equal to K into x by m to the x by m. This is used for gases and this is used for liquids. That is nothing but what are adsorption isotherms are nothing but the curves or plots that gives a relationship between concentration of the adsorbent and the concentration or pressure of the adsorbate. So now using those conditions and those graphs, we have developed an equation called Friendly's equation, which is given as C star is equal to K by x by m to the power of m for liquids. P star is equal to K into x by m to the power 1 for gases. C star and P star are the concentration and pressure. C star is the concentration of adsorbate or the solute particles, you can say. Adsorbate of the solute particles in liquid state. Concentration of adsorbate or solute particles in liquid state. Whereas P star is the partial pressure. Of adsorbate, or you can say solute, in gaseous state. And x by m is nothing but defined as the amount of adsorbate or else you can say an amount of solute per unit amount of adsorbate or amount of solute per unit amount of adsorbent. Or you can say solid. So this is what is the relation that is of Friendly's equation. Generally, in general we write this as y is equal to m into x to the power of n. This is a general relation we write. That where this x is x by m, n is equal to 1 for gases, n is equal to n for liquids, and for liquids you will take y as c, and for gases you take this as p. So this is the general equation we write. Y is equal to mx to the power of n. ln of y is equal, if you apply log on both sides, ln is equal to ln m plus n into ln x. ln y is equal to n ln x plus ln m. So this is of the form y is equal to mx plus c form. So Friendly's equation, a system or a process is said to be follow Friendly's equation if the ln y versus ln x graph obtained is a straight line. So basically this you write in general as y is equal to m into x to the power of n, and if you apply ln on both sides, ln y is equal to ln m plus n ln x for, so this is of the form ln y is equal to n ln x plus ln m, so y is equal to mx plus c form. So a system or an operation is generally said to be following Friendly's equation if the plot of ln y versus ln x is a straight line. It is a straight line. In problems they might ask you, he'll give you the equilibrium data and he'll tell you to determine whether it follows the Friendly's equation or not. Okay, so this is what is your adsorption isotherm and Friendly's equation. Now let us begin with the single stage operations. Single stage adsorption. So you consider a single stage through which the solute, the fluid is entering, right? The fluid is entering, which consists of the solute particles of compositions y0 and y1. Consider SS, which is the solid adsorbent, which is entering and leaving the single stage in counter flow direction, cross flow with the compositions x0 and x1. LS and SS are the weight or amount of fluid or amount of solution, you can say, and amount of solid or adsorbent respectively. LS and GS are the amount of fluid or amount of solution that is entering. SS is nothing but the amount of adsorbent, or you can say amount of solid that is in contact. Okay, X is nothing but amount of adsorbate, that is amount of solute. Adsorbate, that is amount of solute per amount of adsorbent. Amount of solute or amount of adsorbent per amount of adsorbent, which is solid. And Y is amount of adsorbate per amount of solution. That is nothing but, X is nothing but the amount of adsorbate per amount of adsorbent. Means the how much of the solute particles are settled on per amount of solid. For if this is your 1 unit mass of solid substance or adsorbent, how much amount is settled or how many solute particles are settled on the solid surface, that is given by X. And generally this X0 will be 0 because initially when the solid comes initially in the contact with the liquid or the fluid phase, initially there are no solute particles settled on this solid. Henceforth that X0 will be generally 0 unless it is specified. Y value is nothing but the amount of solute particles that are present in the solution which will undergo adsorption. Right? The fluid itself consists of solute particles on the adsorbate, right? That are undergoing adsorption. So it is nothing but the amount of adsorbate or solute particles present in the amount of solution. So X and Y. Now writing the material balance equation for this. Writing the material balance equation, Ls into Y0. Inlet, what is material balance? Component balance. Inlet is equal to outlet. So Ls into Y0 plus Ss into X0 is equal to Ls into Y1 plus Ss into X1. So you get on separating minus Ls by Ss by Gs is equal to minus Ss by Ls is equal to Y1 minus Y0 by x1 minus x0. x1 minus x0. Now this is this general. I hope you are clear with this, right? Material balance inlet LS into Y0 plus SS into X0 is inlet is equal to outlet LS into Y1 plus SS into X1. On simplification you get minus SS by LS is equal to Y1 minus Y0 by X1 minus X0. Generally this X0 is termed to be 0 because initially there is no adsorbate or solute particle settled on the adsorbent. So x0 will be generally taken as 0. Now if the system or if the process follows the Friendless equation, then what is y? X m into x to the power of m. So from this what is x value? Y by m to the power of 1 by n, right? So you can write this equation as minus ss by ls is equal to y1 minus y0 by x1. So this will be x1 y1 by m to the power of 1 by n. This is the equation, and if the system or the process follows the Friendless equation, that is y is equal to mx to the power of m, from this you can calculate x as y by m to the power of 1 by n, and x1 will be y1 by m to the power of 1 by n. So this equation can be written as y1 minus y0 by x1 is y1 by m to the power of 1 by n, and x0 is anyway 0 because initially there is no solute particle settled on the solid surface. So this is about your single stage operation. So this is your single stage operation with the operating line equation as with x1 comma x0 comma I'm so sorry. This is the operating line equation. This is the operating line equation which passes through the point x0 comma y0 comma x1 comma y1 x1 comma y1 with the slope minus ss by s. This is the equilibrium curve. Okay. So operating line equation which passes to the point x0 y0 and x1 y1 with the slope minus ss by ls. Now let us move to multi-stage counter flow process. You have seen about single stage now. Now we will see about multi-stage option. We will discuss about multi-stage process. In multi-stage process, assuming first, second and so on, let us take, and nth stage you consider. Okay. So first of all we will take the fluid that is nothing but adsorbate. We will take the adsorbate to pass in this direction. This is your adsorbate, or you can take it as solute. Okay, so initial concentration entering will be y0 and leaving will be yn, right? Here you have y1, y2. Now the solid particles come in contact with this fluid in counter flow direction. So reverse. This is your adsorbent. So it is entering from n plus 1 stage, right? So xn plus 1. This is xn, x2, and it leaves at x1. So the initial concentration or initial composition of the adsorbate or the solute is y0, leaving composition is yn, and initial concentration of the adsorbent or the solid is xn plus 1 and leaving concentration is x1. So now for this entire stage, if you write component balance, what is enter? This is ls and this is gx, ss and ls. Now if you write component balance, ls into y0 is entering plus ls plus ss into xn plus 1 entering at this direction, right, is equal to, leaving is what, ls into yn plus SS into x1. It is same as that of your single stage only, but here the fact is you have multiple stages, right? Entering, leaving, inlet is equal to outlet. Be careful with that. Okay. So from this you get Ls into y0 minus yn is equal to Ss into x1 minus xn plus 1. So Ss by Ls is equal to y0 minus yn by x1 minus xn plus 1. y0 minus yn by x1 minus xn plus 1. This xn plus 1 generally is equal to 0 because initially the adsorbent has no solute particles settled on the adsorbent. Okay, generally 0. Okay, so this is how you have the, now this is how you do the operating line equation with slope Ss by Gs, y0 minus yn by x1 minus xn plus 1. Okay, for multi-stages, how do you calculate the stages? That I will be discussing in the problems. Now if I discuss here, you will get confused. Okay, so is it clear multi-stage? So you have n number of stages, initial concentration y0, final concentration y0, yn for the solute, entering in counter direction is your adsorbent, which is having entrance composition as xn plus 1 and leaving composition as x1. So inlet is equal to outlet, component balance. So you get Ss by Ls is equal to y0 minus yn by x1 minus xn plus 1. Now everything is done. Now if to get highest amount of purity, to get high amount of purity or more amount of solute, this is your solid surface. If you want more amount of solute particles to get settled on the surface, what is the minimum amount of adsorbent required? Means more separation or more adsorption, but for maximum amount of adsorption, what is the minimum amount of solid or minimum amount of adsorbent required for the solute particles to settle is the aim now. So basically, what is the equation? Ss by Ls is equal to, what we got? Minus yn, y0 minus yn by x1 minus xn plus 1. Yn minus y0. Just a moment. y0 minus yn by x1 minus xn plus 1. Ss by Ls is equal to y0 minus yn by x1 minus xn plus 1. Now, in generally, initial adsorbent will be 0, right? In counter current flow, xn plus 1 is, just now in multi-stage we have seen xn plus 1 is the entrance of the adsorbent, initial composition. This is generally 0 because there is no solute that is being settled on the surface initially. So, leftover will be Ss by Ls is equal to y0 minus yn by x1. So now from this equation we have to derive the minimum value of Ss that is required for maximum amount of adsorption to occur. So maximum amount of absorption to occur. So what should happen? More and more amount of solute should get settled on the solid surface. That means what is x value? What is generally x given as? Amount of adsorbate or amount of solute, you can say, settled per amount of solvent or solution, right? Per amount of solid or per amount of adsorbent. Amount of solute per amount of solid is x value, right? So to have this minimum amount of solid required, what is the minimum amount of adsorbent required? What you should have, this value should be maximum, this x value. So more and more solute particles to get settled. That will only give you the minimum value. Maximum adsorption is what? More and more solute particles should settle on that solid material. For that, what is the minimum solid required is our aim. So this x1 value, this value should be maximum. Henceforth, you have to calculate x1 max first. You have to calculate x1 max first to determine the value of SS minimum. So what do you do is, as usual, you will take XY data first. You will plot the XY data. This is your XY curve that you get. XY data or XY curve that you will plot. So now, you know the points. Now if you have the multistage process, this is your Y0, this is your Yn, this is your Xn plus 1, this is your Xn, right? So you know the values of, X1. You know the values of initial entering concentration of the liquid, you know. And final composition of the liquid also, you know. Final amount of solute also, you know how much it is there. So Y0, Y1 values, you know. But what is the amount of X1, that is how much amount of solid that is settled, we have to determine. So what are the points? X1 comma Y0 and Yn, Xn plus 1 comma Yn are the 2 points. Xn plus 1 is generally 0 because it is the entrance of the adsorbent, because initially there is no solute settled on the adsorbent, so this value will be 0. So you have point Yn here. This is your Xn plus 1 comma Xn plus 1 comma Yn value. Now you know the Y0 value, right? You know this concentration of Y0. This is over. This is, forget it now. You don't have any use of this now. Now Y0 initial composition, you know of the solute how much it is there. So this is your, say, Y0 value. For this Y0 value, draw a straight line parallel to this X. Right? Now, after drawing the straight line, plot a straight line passing through this Xn plus 1 comma Yn point. You already pointed, right? From that point, you should point a straight line. Such that it cuts this equilibrium curve as well as this line which is parallel to x-axis. Xn plus 1 comma Yn you already plotted. From that point, you should draw a straight line which cuts this line at certain point and equilibrium curve also at certain point. So this point, from this point, when you drop down a line to x-axis, the point where it cuts the x-axis is your x1 max. This is your x1 maximum value. So therefore your SS minimum will be given as Ls into Y0 minus Yn by x1 max. This x1 max is obtained from the graph. Clear? Minimum value of SS to obtain, you will consider this equation in the counter flow direction. Xn plus 1 is generally 0 because the initial amount of solute particles settled on the adsorbent will be 0. Henceforth, for this SS to be minimum, X1 should be maximum because more amount of solute that settled on the solid gives the minimum amount of solid required, right? Because X value is what? What is X? How do you calculate amount of solute per amount of adsorbent? So to X value to be maximum, more and more amount of solute should be settling. So if that X value was maximum, then the minimum amount of adsorbent that is required we can easily determine. So what do you do? For this process, you know the Xn plus 1 value which is generally 0. Y0 value is known, Yn value is known because they are the compositions of the fluid solute particles that are developed from the fluid. So the points are x1 comma y0 and xn plus 1 comma yn are the 2 points through which this line passes, right? So xn plus 1 comma yn point you know, xn plus 1 you know, yn you know. So you pointed that point. Here you don't know x1 value, how much amount of solute is adsorbed, we don't know. So but y0 you know. So from that y0 draw a straight line parallel to the x-axis. From this point xn plus 1 comma yn, draw a straight line such that it cuts this line which is parallel to x-axis as well as the equilibrium curve at a certain point. From that point, drop down a line to the x-axis. The point where it cuts this x-axis is known as x1 max. So this is how you determine your x1 max value, and this x1 max value will help you to determine the SS minimum using this formula LS into y0 minus y1 by x1 max. Okay, thank you.